Yeah? Excellent. Okay, so we are back with another wonderful math lesson. So we're going to do infinite geometric series. Good stuff. And then it's our last lesson and then we're done. So basically you have an infinite number of terms, never ending terms. And we're going to go ahead and calculate the sum of that. Okay, that's what an infinite geometric series is. So it'll give us enough info so we can grab like the information we need. That's the notation for it. So we go S and then an infinity symbol, and that is called the sum to infinity. Sounds like a superpower. I'll give you a moment. Close the door. Okay, so let's take a look at a couple. If you want to add that title, estimating some sums. So first we'll just do it, we'll just kind of estimate. Believe it or not, we can estimate an infinite sum. It sounds crazy, but it's totally doable. So we got 3 examples here. Because there's basically 3 things that can happen, I think. So it says, determine whether each infinite geometric series has a finite sum. And then it says, estimate each finite sum. So we're going to add them up by hand. So an infinite series, so that means never ending, that has a finite sum. Finite means like something we can calculate, like it ends at some point. So that's an interesting concept. But if you look at A, what's their common ratio real fast for A? Yeah, a half, right? If you go this one divided by that one, you'll get a half. So it's like, okay, every time I'm multiplying by a half, it gets smaller and smaller, right? So let's go ahead and look at, there's the sum of the first term, and then the sum of the first 2 terms would be 3/4. And I don't know like how much of this you want to write down. It's sort of up to you. Like it's more like what happens is what we're looking at here. So then when you do the sum of the first 3 terms, I just took this and then added the next term, term number 3, which is an 1/8. So you get 7/8. And then when we do the sum of the first 4, so again I took this and added the 4th term, 1/16. And you're getting 15/16. And I'll do one more. So there's the sum of the first 5 terms. So a couple things to think about. As we keep calculating terms, so this was the 5th term, what's the next term? If we use the r of a half, it's going to be 1 over what? 64, and then it's like 1 over 128, 1 over 256. Like, what's this getting closer and closer to? Not quite 0, right? 1 over 256, like this number keeps getting bigger, this stays the same. So eventually we're basically going to get to 0 at some point. So the idea that, hey, like, yeah, it's an infinite series, but it's kind of like approaching 0. So like, could we calculate a finite sum? The answer is yeah. And it turns out, it just works out this way, you don't need to calculate very many sums before you actually start getting close to the number that it's approaching. So as you can see, this is 0.75, right? And then what's this approximately? Someone have their calculator? Right, so we're like at 3/4, 0.75, and then we're at point, like, what is it? 875, okay. And then this one. Thank you. Right, so, and then this one is like even like 0.9, who knows, 4 or 5, I don't know. So what does it seem like you're getting closer and closer to? Yeah, 1. So, and again, it's just a guess. Like we'll have a formula in a minute, but yeah, it's like, it seems like it's approaching 1. So you can kind of guess and say, okay, so the infinite sum is probably close to 1. So just like, this is just food for thought, okay? So it's like, all right, there's 1. Now the second sequence here, it's growing, right? So our R value is actually 2. If you go 1 divided by 0.5, you get 2. So I can see it's multiplying by 2 every time. So the infinite sum for this one would be just a number that gets bigger and bigger, right? You guys agree? Right, because like think about it, like I'm going to start adding these together. What's the next number? 8, and then 16, and then 32, and then 64. Like, will that ever like approach a number? No, in fact, we would have called this divergent a few lessons ago. So this is divergent because it just keeps getting bigger and bigger. So when you calculate the infinite sum or even a finite sum, you're never going to get to a number like you did here, where this one's getting closer and closer to 1. Okay, so here's the work. And again, it's just food for thought, so you don't necessarily need to write it all, but you can be like, sum of the first term is this. By the time you get to the fourth term, you have 7.5. It's just going to get bigger and bigger. The important thing to write down would be this. So the sum will always get larger. So there is no finite sum. And in brackets, well, that's a divergent series. Because we're going to come up with a generalization in a minute here. Okay, so that's a thing that can happen. So we looked at 2 examples. One of them that converged to a number when we did the finite sum. Another one that diverged, so there is no really number that it homes in on. And then part C, well, this one's alternating. Okay, so it's alternating. It's also getting smaller. Like, what's the R value here? Yeah, it's -0.5. Very good. So it's very similar to A, except it's negative instead of positive. So if you start expanding this, if you were to write some more terms, you guys can write it beside. I sort of ran out of room, but the next term would be +1 over 32, and then the term after would be -1 over 64. And then +1 over 128. So I don't know what's going to happen. Is this converging on something? Is it converging on a number?
Closer to 0.
Yeah, closer and closer to 0. You're above 0, positive, and then you're below 0, negative, but you're closer to 0. And then you're above 0, positive. Like, if this is 0, like you're kind of like here, and then you're a little bit closer, and then closer, and then closer, but you're alternating above and below if this is positive and that's negative. So you're homing in on 0, but you're just jumping on each side of the line, and then eventually you'll get to 0 if you think far enough out. So let's see what happens to the sums. And I would never, like, we would never get you to do this by hand. This is for demonstration. So like, first one's a half, then we get a quarter, then we get 3 over 8, then we get 5 over 16, then we get 11 over 32. I think I did a bunch because it's not clear what's happening. Like, let's see. I'll just give you a moment if you wanna just write down like just what the sum is. That would be good. Yeah, I can go up. Again, it's not like you're gonna get tested on this, but it's just for your own background information, like where a formula kind of comes from. So I started writing the decimal number because I couldn't quite, like, this is 0.25, this is, I don't know, 0.3, so I don't know, 0.2 something. Anyways, by the time we get to the 5th term, the decimal approximation is 0.34, and then it jumps down, right, because we're subtracting, so it actually gets smaller, 0.312, 0.32, and if we did one more, I don't know if we need to, what does it, can you guys guess maybe what it's getting closer to? This last number is actually basically the one. Here we can do one more. So if you take this, you type that in on your calculator, okay, and then the next term would be subtract, multiply that by half, 1 over 256. Well, that's the thing, is the number you're subtracting keeps getting smaller, right? But I don't think it's getting closer to 0. But let's see what this one is. Maybe we don't have enough. Just type it in on your calculator. Let's just get a decimal. 3164. Perfect. Okay, so it was 0.312, and then it went up to 0.32, and now it's back to 3164, so slightly bigger. Okay, so if you did the next one, you're going to find that it's actually homing in on something like that. It's homing in on 0.32. Right, because that number that you're adding and subtracting is slowly and surely getting smaller and smaller. So it homes in on something. So here's the important conclusion you need to write. So the series alternates up and down, but perhaps it'll converge to maybe like 0.33 or 0.32. Remember, we're just estimating, so I'm going to say about a third. Seems like a nice number. Okay, I'll show you the formula. I just wanted to show you the 3 things that could sort of happen. I guess it's not really 3 things. I wanted to show you 3 different examples So there's two things that can happen. It can either converge in a number or it can diverge. And it turns out there's an easy way to figure out what's going to happen without doing a ton of work. And roll right. Good. You guys are adding this to your notes, right? Sure. Everyone's good? Yeah? Okay. So, well, we don't even have to. Well, okay. Here's our formula from the other day. And this is just an exercise to try to see what happens if you take a random sequence and you start messing around with the R value. I think I'm going to sort of skip this because I just want to get to the formula. Like if you use a large n value, what happens is if, like, say you make your R 0.99, right? And because you're summing to infinity, like n's going to get really big. Basically what starts happening is this part of the formula, actually becomes 0. As long as your R value is between -1 and 1, not inclusive. So if you have a decimal R value that is bigger than -1 but smaller than 1, this part of the formula goes away. Alright? So then what happens is, okay, so the sum to infinity is t1 divided by 1 minus r. And that's where our formula comes from. Okay? So like if you were to try let's just try one. If you try 0.99, let's just say that's our R value. And you do like 1,000 for n. Do we get basically 0? What does your calculator tell you? Yeah, basically it's just gone, right? And when you're summing to infinity, n will be 1,000, 10,000, 100,000. So eventually what happens is this goes away. And your formula just becomes 1 times t1. So, I think I have it here. This becomes your formula. It's just the sum to infinity ends up being your first term divided by 1 minus r. And that's just coming from the formula we did last week, which was just finding a sum for a geometric series. The thing is, the stipulation is that r must be between -1 and 1. Okay? So this only works if your r value is between -1 and 1. If it's not, so if your r value doesn't fall in there, then it actually diverges, and I think it says that in here. Now, it doesn't say it in here, but I'm just going to say, if this is not true, so if that's not true, then there is no infinite sum. And the reason that is because the series will diverge. Like if your R value is not between those two, your series will diverge. So we'll write series diverges. So you will get a couple theory questions that might say, hey, here's a series, here's a geometric series, does it converge or diverge? Right? And all you got to do is be like, well, the R value, is 3. So it's not between -1 and 1, so it diverges. That's all you'd have to say. We'll do a couple of examples right away. Are you guys ready? So the calculations aren't very hard. You just have to sort of know the theory, that's all. Alright, let's take a look at our second example. And let me know if I'm going too fast. I don't have enough time to write down. I'm happy to pause. I just need to know. I try to watch your pencils, but... so determining the sum of an infinite geometric series. So there's two questions here. It says determine whether each infinite geometric series converges or diverges. Okay, so that's the first thing. And if it converges, determine the sum. So let's take a look at this one. What do we need to multiply by to get there? So that's my formula, right? Term 2 over term 1. And that reduces down to, I think, -1/3. Do you guys agree? Yeah? So, is my R value between -1 and 1?
Yeah.
Yeah? Okay, so you would say, since R is between -1 and 1, the series converges. So that answers the first step of the question, does it converge or diverge? And if it converges, then we can find the infinite sum. So I'm going to write my formula. So there's the infinite sum. It's term 1 over 1 minus r. And I'll pop my numbers in there and I'll get a sum. So term 1 is 27. Now be careful in the denominator. R is negative a third, right? So we go 1 subtract negative a third. So when you type that in on your calculator, you just want to make sure that you go 1 plus. So I'll tell you the answer I got. That gives me 20.25. So there it is. That's everything the question is asking for. Pretty easy. Any questions about A?
Can you go back a bit?
Yep. Back to the writings?
Yeah, just because,
Down there.
is that 6 over P, or, like, since R is,
Right here?
no, like, it says since R is.
Oh, that's B,
Yeah.
B slash T, between.
Okay.
Yeah, that's my shorthand for between. That's a good question there. Yeah, when you're writing notes, like just anything you can shorten, like you're gonna want to do. So like the ones I use, like B slash T is between. That means that's the. Apparently, someone told me that's the universal symbol for therefore. I think that's about it. B slash C because whatever, little things like that. Okay. So is there anything else before we move on to the next one? You guys look absolutely amazed and thrilled. Hey, if you want to do something fun, come build a robot with us in the robotics club. There we go.
Meetings tomorrow, right? Or is it today?
We'll do Thursday. I can't do Wednesday this week either.
I typed this into my calculator. 27.3.
It won't be 27.3 for sure because 27 divided by 1.3 is going to be a smaller number, right?
Yeah.
27 divided by 1 would be 27. I'm dividing by a bigger number, so maybe just check. I can see you later if you're still having issues with that. Okay, part B. So let's see what happens. The R value, so if I go from there to there, and I just go this term 2 divided by term 1, ah, shucks. That's negative 2. So is this series going to converge or diverge? Yeah, so you just say since R equals negative 2, and negative 2 is not, and be careful, I'm going to go B slash T is not between negative 1 and 1. It's not picking up the marker there. The series diverges. So the series diverges, and there is no infinite sum. That's so sad. That's so sad. There is no infinite sum. Isn't that sad? So sad. You guys look like you're sad about that. Any questions? In grade 12, you have all these explain questions. There's 10% of the exams explain questions. So get used to, like, that's why I'm doing this, like just writing a sentence. So state your reason why, state the solution, and then that would, you'd be ready for grade 12. Lots of people have issues with those questions. And it kind of sucks. It's like, oh, there's like all this English in the math exam, but it's kind of inevitable, I guess. Any questions before we do the next one? Like, does this seem pretty doable? Like, we got one more formula. It's a relatively easy formula, but you need to remember that theory part, that R needs to be between negative 1 and 1. If you can remember that, then you should be able to do this, and it's just another little tiny topic. So here's another one. So example 3 is using an infinite geometric series to solve like a problem. I always use problem in quotation marks because when I read these, like, there's really no problem here. It's like they give you all the information you need. A problem we're having is how do we hook up that robot, hey Mason? Man, that's a problem. How do we program it? I don't know anything. I'll give you a moment to write that title. People on YouTube will see this in 50 years and they'll be like, they built the robot that took over society. There's no risk of that. We have no idea what we're doing. Okay, everybody's got the title? Great. If the sum, so they're telling us the sum of an infinite geometric series is 25. So I'm like, all right, let's start writing down our information. That's a great first step. There's the sum of the infinite series being 25. The first term is 20. Find the common ratio. Well, the only formula that I have that has to do with the infinite sum is this one. So honestly, the biggest mistake is people try to go to the other formula. So the one we did the other week was this. Right, that's the one we did the other week, but that's if you know what n is, right? Like, this formula will not work for an infinite sum. This is the formula for infinite sum. So, just pop in the numbers and solve. So, the sum is 25, term 1 is 20, and then it's over 1 minus r. Just have to solve that. Now, we'll do a whole unit on rational expressions. But I think from like grade 9 or grade 10, you should know how to solve this. When your variable's in the bottom, you need to multiply both sides by the denominator. And that's usually the case. So I'll multiply both sides by that. Just use brackets, because we'll have to use the distributive property. So when you go a number divided by itself, you just get 1. And now I have on the right-hand side, I have 20. This is a step I'm worried about. Is everybody okay with that step? Right, like the equivalent back to grade 9 would have been like if you had like x over 8, right, equals like something, right? And then I said, oh, you got to divide, you got to isolate the x. We'll just multiply by the denominator on both sides, right? 8 divided by 8 is 1. It's the same exact concept, just as this is a polynomial. Does that sort of ring a bell? Yeah, I noticed that students seem to have trouble with that, so. There it is. Over here, well, you need to use the distributive property because it's not just r, it's 1 minus r. So this 25 goes in on both sides. So you can go 25 minus 25r. There's an easier way, but I'll just leave it. Now just isolate r. So subtract 25 from both sides. So on the left-hand side, you'll get negative 25r equals, what's 20 minus 25? Negative 5, okay. Divide both sides by negative 25. So you get negative 5 over negative 25. And then clean it up. Right, so negative divided by negative is positive. 5 and 25 have a common factor of 5. So at the end of the day, you get 1 over 5. And like, does our answer make sense? Like, if you can find an infinite sum, should this be between negative 1 and 1? Yeah, and it is. It's 0.2. So that's all good, hunky-dory? Alright. Guys, that's exciting. I'm excited because we're almost done with notes. I think, is there one more? No, it's not. Okay, yeah, this is like outdated. You guys are going to do exercise, whatever the next one is. I'll stop the video there. I'll tell you in a sec. Thanks for joining us. Bye.